Greetings and welcome to your pre-algebra session of the week. We are in the week of December 8th and it's also the week 16. So when you go to do your assignments this week, make sure you're looking for the week 16 marked folders. Let's go ahead and make sure everybody's got their math notebooks out at this time. And in your math notebooks, I do want you to practice finding the slope between, let me try that again. I would like you to find the slope between the 2 points. So you're going to find two different slopes here. The first slope you'll find is between the 0.54 and 2,1. And then the second slope you'll find is between the points -3,4 and -1 and -5. So notice that second problem that you're going to do does have some negative signs in there. So do make sure that you are putting the proper number of negative signs in. And for those of you who might need a quick reminder of slope, remember slope is the change in y's coordinates. So you subtract your 2y coordinates over the change in your x coordinates. So that should get you going, and go ahead and try these problems in your math notebook. We will be using the idea of slope again. We're going to apply it to a different concept. I know we learned it back in Unit 4, and now we're using it again in this unit. So I want to make sure that everybody remembers how we find slope between 2 points. So go ahead and click pause now, and when you're ready to check your work with mine, go ahead and click play. All right. So here, number 1, we're going to find the slope between 5,4 and 2,1. So let's remind ourselves of that formula. We find the change of y's over the change in x's. So if we want, we can go ahead and label our coordinates as x1 and y1 and x2, our second x coordinate, and our second y coordinate to help us plug into the formula. So we're going to take the second y coordinate, which is this coordinate, and subtract it by the first y coordinate. So we're subtracting the y coordinates. So we're going to have 1 minus 4 divided by, and we're going to do the same thing for the y coordinates. We're going to take the second y coordinate minus the first x coordinate. I'm sorry, the second x coordinate minus the first x coordinate. We're on the x's now. So that would be 2 minus 5. Now let's do the math. What's 1 minus 4? -3. And what's 2 minus 5? That is also -3. So we could either leave our slope as -3 over -3, or we could say that we know -3 divided by -3 is a +1. So that slope of a +1, remember we could always rewrite it over the numerator or the denominator 1 so that we get our horizontal movement. So a slope of 1 would move up 1 and to the right 1. All right, let's try number 2. So we're going to use the same formula, change in our y coordinates over change of our x. So let's go ahead and label our coordinates if that helps you. The first x coordinate, the first y coordinate, the second x coordinate, and the second y coordinate. So we're going to subtract our y coordinates, our second y coordinate, which is -5, minus our first y coordinate. And we're going to do the same with our x's. We're going to take our second x coordinate, which is at -1, and we're going to subtract it by -3. So note that there's two negatives there, and that's because we're subtracting -1. We're subtracting it from -3. So we get that double negative in there. So let's go ahead and do the math now. -5 minus 4. So we're at -4 degrees. We drop 4 more degrees. We're at -9. And then whenever we have a double negative, that turns into a positive. So really we've got -1 plus 3, or 3 minus 1, which is 2. So here's our final slope. Good. And we will be using this this week, the idea of slope. So let's see how we're going to see it. So this week in the live session, we're going to go over everything in Unit 6 so far. I know we did Unit 6 Session 1 last week, but we didn't have a chance to go over it in our weekly recorded session. There just wasn't enough time. So even though you guys did Unit 6 Session 1 last week, I'm still going to go over the concepts in today's recorded session. But this week, these are the 2 assignments that you're working on, 2 sessions. Is Unit 6 Session 2 in Unit 6, Session 3, where we're going to look at different ways we can represent functions and then different ways we can write linear functions. So let's jump right in. Oh, so before we do get going, some important reminders and dates for the next 2 weeks. We only have 2 more weeks left in the semester. That is pretty darn cool. However, it's important that we know what's coming up next week. So the last day of the semester next week is December 18th, next Friday. So next week I'm going to assign you work on Tuesday, and you'll have until December 18th at 3 o'clock to get your work done. I will not be assigning as much as I normally do because we kind of have a short week next week with it being the end of the semester. And this is the really important one. The last day for turning in any late or redos is December 16th. So I will not accept late or redo work after December 16th. That's next Wednesday, guys. That's next Wednesday. So please have a plan if you're working behind in the class to get caught up by then, or if you wanted to redo assignments to get your grade to a certain grade, that you do that. But remember, the only redos I'm accepting right now should be coming from Unit 6. We only do redos for the current unit we're working on. So the only redos you should be doing are from Unit 6 right now. So again, just remember, redos and late work due by next Wednesday. So make sure you write these dates down right now somewhere. All right, well, let's talk about functions. So Unit 6 is all about functions. Unit 6 is all about functions. And let's talk about what a function is. So let's imagine that we've got this machine. Here's our machine. This thing right here is our machine. When we put a number into our machine, something happens inside the machine to that number, and out pops another number. So that's kind of what a function does. You plug in one number, and then you apply that number to an equation, and then you get another number that pops out. So our inputs, what we put in the machine, is always going to be our inputs, our x values. So whatever we put in the machine is going to be our x values. Whatever comes out of the machine is going to be our outputs, or our y values. So when we think about a function machine, we're really talking about a function equation. So let's think about this. We're going to put an input value, which is going to, remember, be our x values. So remember, our x values go in to the machine, and then out pops your y values. But let's talk about a specific function here. So here, let's plug in the number 12, and then something is happening inside the machine and out pops 24. So think about how we can go from 12 to 24. Now we put 5 into the machine, and out pops 10. So think about how we can go from 5 to 10. So we want the same pattern to go from 12 to 24. If we plug input 3 and our output is 6, how did we go from 3 to 6? And lastly, if we put in 7 and out comes 14, how do we go from 7 to 14? So can you guys think of a pattern that's happened to all of our inputs to get our outputs? So if you said that each number is doubling, that is a great pattern. So what we could say is that our pattern is going to be 2x. So that would be our function, would be 2x. And the way that we would write that would be y equals 2x. And remember, our input is always the x value, and the y is always the output. So a lot of times you're going to see function notation written, instead of just writing it, I'm going to erase this so I can write up here. Instead of writing just y equals 2x, a lot of times you're going to see fancier notation, and you're going to see f of x equals 2x. And the f of x really just stands for our output, or our y value. So you can see that really I substituted the y with f of x. So that tells us whatever number is in the parentheses. So you might look like this, f of 2 equals 2x. And what that is telling us is that wherever you see an x, you want to plug in 2. So f of x tells you wherever, what's numbers in the parentheses of the f tells you wherever you see an x, plug that number in. So f of 2 would equal 2 times 2, which would be 4. And I think we'll get more practice with that in just a moment here. So let's talk about what makes a function special. So whenever we put an input in, or we plug in an x value, a number for an x value, you will never get 2 or more results for the same input. So what that really means, a better way to put that is for every input, you will get only one output. So in order to be a function, you will never get 2 or more results back for the same input. So what that means is, I kind of wrote that. For every input, you will get only one output. That's really what's being said here. I just reiterated this. This is an important one. A function is a set of ordered pairs in which each input, x input, only has one y output. If you find that when you put an x value in and you can get 2 different values out, 2 different y value outputs, then that's not a function. So for every input, there's only one output. That's what makes something a function. So make sure you write these down in your math notebook right now, is what makes a function special. I really like this last one. For every input, there's only one output. That's my favorite one for what describes a function. So we're going to look at that. So let's look at an example. So if we have like y equals 3x, any number we plug in for x, we're only going to get one value out for y. We're only going to get one value out for y. Here's an example of one where we could get 2 different outputs. Y equals x squared. So if I plug in x equals 1, what do I get? If I plug in x equals 1, then y would also equal 1 squared. 1 times 1 is 1. If I plug in x equals -1, -1 squared is the same as saying -1 times -1, y would also be 1. So look what happened. We we've got the same output here. We've got a y of 1 and a y of 1 when we inputted 2 different numbers. So because for every input there should only be one output, this is not true. So that would mean that at y equals x squared is not a function. Not a function. So that was just an example of where you could have this same output for different inputs. Alrighty, so last week you looked at relations. And I just wanted to review this just to make sure that everybody understood this concept of relations. And it's a different way of writing out a set of ordered pairs. So remember, a set of ordered pairs like your x and your y's. An ordered pair is like 1, -3. So if we were to put that in a mapping diagram, I could put 1, -3, and I would draw a line from 1 to -3. So these would be my inputs over here on the right, and these would be my outputs over here on the left. So let's keep going. Let's say that we've got 2 and -6. So I could put that in the mapping and draw my arrow to the what goes together. I could say 5 and -15. That would be another. So I got you guys going on the ordered pairs. So what does it? So I want you to tell me. I told you the first 2 ordered pairs. So I already gave you this right here, the input goes with that output, and it would create the ordered pair of 1, -3. So the input, remember, always represents your x values. So 2 goes with -6, so the ordered pair would be 2, -6. So what would be the ordered pair for this set? It would be 5, -15. And then what would be the ordered pair for that 7 point, and it's got the arrow to -16? It'd be 7, -16. So looking at this relation in the mapping diagram, are the ordered pairs from the mapping diagrams, are they a function? Are they a function? So we already wrote these down up above. Is that a function? So really what you should do is start by looking at your outputs. So remember, your outputs, there should only be one output to every input. And in this case, there is. So that means that yes, this is a function. This is a function. Okay, so let's go on to the next slide. I'm going to do some different numbers here. All right, first step, let's what are the ordered pairs? What are the ordered pairs? So always start with your input, because your inputs are always going to be your x values. Start with the first one. What is that first number? What is it pointing to? 1. 0 is pointing to 1. So that means our ordered pair would be 0, 1. Our next one is 2, 2. Our next one is 4, 3. And our last one, 6, is also pointing to 3. So now, is this a function? So remember, all of our outputs should only be pointing to one input in order to be a function. So the outputs should only have one input if it's a function. So let's look here. There's only one, this output only has one input. This output only has one. This output has 2 different inputs. So the inputs, there's 2 different inputs that are giving that value of 3. So that makes this not a function. So remember, the definition of a function is that there is only one output for every input. So here we've got 2 inputs giving us the same output, and that makes it not a function. Okay, I'm going to move on to the next slide, so if you need more time, go ahead and click pause. All right, so a lot of times you're going to be asked to evaluate a function. So here, if the function rule is y equals 5x minus 8, that's our function rule. Y equals 5x minus 8. We want to find the output if the input is 2. So in other words, remember, the input is always our x value. So our input is always our x value. So if x equals 2, what is y? Well, we've got all the information that we need to solve this. So remember, our function rule is y equals 5x minus 8. And if we're told that x equals 2, that means whenever we see an x, we're going to plug in the value 2. And then we'll evaluate for y. So here's an x, 5 times x. We know x represents 2, so I'm going to substitute a 2 in for x. And now let's just do the math. 5 times 2 is 10. 10 minus 8. Remember, this is what y is going to equal. So y is going to equal 10 minus 8, which is 2. Y would equal 2. Our output is 2. Remember, they might get fancy on you, and they might say that same pattern, but say f of x equals 5x minus 8 instead of saying y equals. And then it would be given to you like this: find f of 2. And that means that x equals 2, because instead of writing x, we wrote in 2. So we would do the same thing. Whatever we saw on x, we would plug in 2. And we would get that same answer, no matter what notation we use. All right, let's look at number 2. I want you to try this one on your own. So the function rule here is y equals negative 2x minus 4. If the input is negative 4, input means the x value. So if x equals negative 4, what is y? So go ahead and try this in your math notebook now. If you need to, go ahead and click pause so that you can try this and then check your work with mine. Okay, so our equation is y equals negative 2x minus 4. I know wherever I see an x, I'm negative 2 times x. So instead of putting x in, I'm going to put in negative 4 this time. So it's negative 2 times negative 4 minus 4. Let's do the math. Negative 4 times negative 2, or negative 2 times negative 4. A negative times a negative is a positive, so we're going to get 8 there. 8 minus 4, y equals 4. Y equals 4. When x equals negative 4. When we have an input of negative 4, our output would be 4. All right. So let's go on to the next slide. If you need more time, go ahead and click pause. Graphing lines from a table. We did this in, I can't remember which, this should be Unit 6, Session 2. This should be Unit 6, Session 2. So here we've got the equation, y equals 2x minus 4. And we're going to graph that using a table. We're going to graph it using a table. So what I like to do is I always like to plug in the input 0, 1, and 2. So if I input my x, if I say x is 0, and I plug it into my equation for x, 2 times x, well I'm going to plug in 0 now, minus 4. 2 times 0 is 0. 0 minus 4, oops, is negative 4. So that equals negative 4. So that means when 0 is our input, we get an output of negative 4. So that means the ordered pair is going to be the x was 0 and the output is our y is negative 4. So that's a point. We can plot that point. Let's go ahead and plot it. 0, negative 4, plotted that point. Okay, now if we have an input of 1, so let's look at this input. If our x value is 1 and we're plugging it into the same pattern, we would have y equals 2 times 1 minus 4. What do we get? 2 times 1 is 2. 2 minus 4 is negative 2. So that means our y value, our output, when we plug in 1, is negative 2. So our ordered pair would be 1, negative 2. So let's plot that point. 1, negative 2. Do it with one more point. We always need 3 points before we can draw a line. So let's say our x value is 2 now. So y would equal 2 times 2. We're just plugging in the value into our, remember, this is our pattern. We're graphing this equation right here. So when I have a x value of 2, I'm going to plug that in for x. 2 times 2 is 4. 4 minus 4 is 0. So our y value would be 0. So the coordinate would be 2, 0. Let's plot that point, 2, 0. And then you can draw on your line. So that is how, and that didn't quite go through, that ordered pair there. And that's how you can graph a line by forming a table. So I know last unit we learned how we can graph a line by just identifying the y-intercept and the slope. So which method do you think is quicker? The one that we've already used? So I just wanted to show you guys a different one, a different method. All right, so let's now, this is Unit 6, Session 3 this week, where you will need to determine the function rule if you're given a table. So you're going to be practicing this week in Unit 6, Session 3, where you're going to determine the function rule when you're given a table. So the first step is to find the slope between any 2 points. So remember, slope is your change in your y values. That's why we did this in our warm-up, over your change in your x values. So here, let's find the change in from 3 to 0. So that's our two y coordinates, 3 minus 0. And then let's do it for the same coordinating x coordinates. So we would do 1 minus 0. 3 minus 0 is 3. 1 minus 0 is 1. So our slope is going to be 3, 1. That could work for any 2 points you choose. If you wanted, you could have chosen these two and you would have gotten the same slope. 9 minus 6 is 3. 3 minus 2 is 1, 3 over 1. So you're always going to get that slope of 3 over 1, any 2 points you choose. So what is the y-intercept? So let's review, what is the y-intercept? So remember, the y-intercept is where we cross our y-axis. So it's wherever we cross our y-axis. So your y-intercept is always going to occur when your x-coordinate equals 0, right? Because if we don't go left or right on the x-coordinate, we're just, to get where we cross our y-intercept, we're just going up or down. So the y-intercept always occurs where x equals 0. So here, that's included in our table. When x equals 0, our y value happened to be 0 as well. So our y-intercept here is going to equal 0. So make sure you write this down somewhere, the fact that your y-intercept occurs wherever x equals 0. And then we know that we can plug these values into y equals mx plus b form, what we learned in unit, I think it was 4. So y equals mx plus b. What is the, when we have y equals mx plus b, what does the m represent? M represents your slope. Review here. B represents your y-intercept. Well, now we have both of those, so we can plug those in. We know the slope is 3, so we can say 3x. And then we're going to substitute in our y-intercept, which is 0. So really, our equation would be y equals 3x, because we don't really need to put that plus 0. So those are our steps to go from a table to a function rule, is to find the slope between 2 points, then identify the y-intercept, and then plug those values into y equals mx plus b. So these are 3 steps. Let's do it again. I'm going to go to the next slide, so if you need more time to copy this down, go ahead. So let's do it again. Let's find the slope between, let's find the function rule of this table. Here's our inputs and our outputs. So first, let's find the slope between any 2 points. So I'm going to go, it really doesn't matter which direction you go. We can go -6 minus -1, as long as we do the same order when we subtract our x values. So if you want, you can say -6 minus -1, and then do 0 minus 2. Doesn't matter which order, as long as you do the same order for the other set. So -6, that's going to turn into a +1. So -6 plus 1 is -5, and then over -2. So our slope is -5 over -2, or we can say +5 over +2, because a negative divided by negative is a positive. So what's our y-intercept? Remember, the y-intercept occurs when x equals 0. So let's find where x equals 0. Oh, we're given it. So x equals 0 when y is -6. So there's our y-intercept. And then let's plug those values into y equals mx plus b. So y equals, m is our slope, so instead of plugging in m, we're going to say our slope, which is 5/2 x, and then our y-intercept is -6, goes in for the b. So there's our equation. You'll get practice doing this again in Unit 6, Session 3. I'm going to go on to the next slide. We're almost done. How about if we're looking at a graph and we just have some points like this. You're also going to practice this in Unit 6, Session 3, where you're given points on a graph and you need to determine the function rule from the graph. So we can find the slope, just follow the same rules. Follow the slope, find the slope between 2 points, and then identify the y-intercept. So we're doing the same exact steps, and then we're going to plug it into y equals mx plus b. So what is the slopes between the 2 points? So here you can just count from one point to the next. So how did we go from one point to the next? That's our slope, remember? So we're going up. So the slope between the points, we're going up 2 units. And then we go to the right one. So 2 over 1 would be our slope. Where is the y-intercept? Well, remember that's where we cross our y-axis. So it looks like we're crossing at 4. So that would be our y-intercept. So now we can just plug that into y equals mx. M represents our slope, so we're going to say 2 over 1 x. And then b represents our y-intercept, so plus 4. And that's our equation. And you'll get to practice that this week as well, following those steps. And that's it. So, 2 questions for the key phrase this week. 2 questions. Make sure when you do your key phrase, you're doing it for December 8th, the week of December 8th. So the first one is when is the last day to submit, late, or redo work? And then the second question is explain what a function is. So I talked about how we can determine what a function is. Tell me that. Explain what is a function. And that's it. So I'm going to stop the recording. Have a wonderful rest of your week, and please let me know if you have any questions as you're working this week.